Okay, hello everyone and welcome to this video. In this video I will be showing you how to build an Android app for custom object detection using TensorFlow 2. So you can head over to this article on my website. Go down below under build machine learning Android apps for object detection. I have made these two articles for building Android app for custom object detection using TensorFlow 1 and TensorFlow 2. I've already made a video on this TensorFlow 1 earlier. For now we will be doing this one using TensorFlow 2. So open this article and this is the roadmap, the overview of what we will be doing. So if you read this article, I've explained all the steps in detail over here, so you won't have any doubts. I've also made a Colab notebook for this. Here's the Colab notebook. I've given a brief description of all these steps here as well, but I've mentioned everything in much more detail in this article. So okay, let's begin. If you've seen my previous video on how to train a machine learning model for custom object detection using TensorFlow 2, you'll see that the first 16 steps over here are the same in this video, training a model for custom object detection using TensorFlow 2. If you haven't seen that video, go ahead and check it out. Although I'll also be covering all these steps in this video as well. Okay, so let's begin. We have already opened this notebook. Save a copy in your drive. Connect. Once it's connected, click on runtime, change runtime type, make sure the hardware accelerator has GPU selected. Okay, now let's begin. The first step is import libraries. Run this. Okay, so as you can see, the default TensorFlow for Google Colab right now is 2.5. Now step 2, create custom TF2 training and data folders in your Google Drive. Create a folder named custom TF2 in your Google Drive, and then create another folder named training inside the custom TF2 folder. This is where we'll be saving all the checkpoints during the training process. And then create another folder named data inside custom TF2. Create a folder here. I'm naming this as custom TF2 just to differentiate. As I've mentioned earlier, I've made a video for TensorFlow 1 as well, so this is just to differentiate. Create another folder named training, another folder named data. Okay, so move on to the next step. Create and upload your image files and XML files. Create a folder named images for your custom dataset images, and create another folder named annotations for its corresponding XML files that are the label files for it. And next, create the zip files and upload them to the custom TF2 folder in your drive. Make sure all these images are in .jpg format, as the generate_tfrecord.py script file that I have uploaded and we will be using later on has .jpg written in it. So if you have to use other format images, make sure to make the changes in the script accordingly. I suggest you use .jpg format so you don't have any issues. Okay, so what I've done is I've labeled a few images over here. I've put all these images in this folder named images, and then I've put all the corresponding Pascal VOC format label files, that are the XML format files, in this folder named annotations, and create a zip folder for each of these folders and upload them to your Google Drive in this folder custom TF2. File upload. Okay, while it's uploading, just one thing: to collect images dataset and to label them, I've made another blog on this. You can read about this over here. I've shown how to label images in videos, and I've also mentioned a few labeling tools that you can use. So I've also made a few videos on this. You can find the links to those videos down here at the bottom in this article. So go ahead and check it out to learn how to label images. Now, okay, let's see. Okay, this is done. We can move on to the next step. Step 4, upload the generate_tf_record.py script file to the custom tft folder. This script file is used to generate the record files that we will be needing to train our model. I'll explain that later on. Right now, what you can do is download this from over here. I've uploaded this on my GitHub. Just download the zip file for it and upload this generate tf_record.py script file over here in custom tft folder. I've already downloaded and copied this over here in my desktop. Generate tf record. Okay, that's done. Move on to the next step, that is mount drive and link your folder. Choose your account, allow, copy this, Control V, enter, and this will mount the drive and link your folder. You don't have to write this every time. You can simply write /my drive and that will be enough. Okay, now for the next step, step 6, we will be cloning the TensorFlow models Git repository and installing TensorFlow object detection API. This is the official TensorFlow models Git repository, the TensorFlow model garden that we will be using for training our object detection model. So just run this step. We'll see this clone the models Git repository in our Colab VM. Now since we've already mounted the drive, we'll see the drive here as well. Just simply open the file section in your Colab. This is inside the content folder. We're cloning this models repository in our Colab VM. You can do it in your drive as well, but this takes up a lot of space, so I'm trying to avoid that. We'll just be cloning this in our Colab VM every time. That's not an issue. All you have to do is just run this step. Now this is the official Python package installation method that we have used here. If you head over to my article, I've given the links at the bottom under credits in references. I've given all these links to the official TensorFlow website and all the documentation and references. So if you read these, obviously this will help you a lot to clear all your doubts and queries. Will obviously help you grasp this concept and everything related to TensorFlow and TFLite much better. So as I mentioned, this is the official installation for TensorFlow 2 using Python package. It should be mentioned over here, the TF2 installation guide. We have a Docker installation. Now we are using this one, Python package. Okay, so as of now we don't have to use feature 2020 resolver, as this is the default in Colab's pip right now. So you can just use this like this and that will install it for you. Okay, so we have the models repository cloned over here, and then we've also installed the object detection API, TF-Slim, TF models official. It all has been installed. Now the next step, to test the model builder. This is just to check if the installation above was successful or not. If this gives an error, you have to run all this process again, and there was something wrong in your installation process. As okay, as you can see, it ran all the tests, there was no error. So okay, we can move on to the next step. Step 8, navigate to my drive custom tf2 data folder and unzip the images .zip and annotations.zip files into the data folder. Just run this step. What this does is it unzips both these zip files in this data folder. You can also view it over here in your drive, custom TF2 data. Okay, the images folder has been unzipped. Okay, that's done. As you can see, both these have been unzipped here. Okay, I have all the files here as well. That's good. Okay, you can also view it in your drive over here. This might take a few minutes. Okay, so this has updated this in the drive as well. We have both these folders here. Let's move on to the next step. Step 9, create test labels and train labels folder. We will be dividing the annotations into two folders. The test underscore labels will have 20% of the label files from the annotations folder, and train labels folder will have 80% of the files. Just run this step. Now you have to make one change. Since I have 1370 images, the 20% of that is 274, so I have written 274 over here to move into the test underscore labels folder, and this will move the rest of the images, that is 80%, 1096 in my case, to the train underscore labels folder. You have to make changes here accordingly. Just change this to 20% of your total number of labels. Okay, let's see. It has created both these folders. Now this will have 20% of the labels, and train labels will have 80% labels. Okay, this is the working directory at this point. As you can see, annotations will be empty now since we have moved these label files from annotations into these two folders. Let's move on to the next step. Step 10, create the CSV files in the label map.pbtxt file. We need these files to create the record files I was talking about earlier to train our object detection model. So just run this cell. This will create three files: the CSV file for train labels, the CSV file for test labels, and this label map.pbtxt file. Refresh this, and as you can see, we have these three files over here. Just check to make sure everything went fine. As you can see, the CSV file has this written in it: the file name, the width, height of the image, the class name, and the coordinates for the bounding box. Okay, so check test labels.csv, that's fine. And this label underscore map.pbtxt file has the class name written in it with the ID number. It should be like this. It starts with ID number 1, as ID number 0 is reserved for background. So okay, let's move on to the next step. Step 11, create train.record and test.record files, the files I have been talking about. Run this generate underscore tf record.py script to create these two record files. This is the usage. Just run it. Quickly go over through this usage. Python, the script file generate underscore tf record, the path to your CSV file for train labels, label map.pbtxt file, the path to it, the path to your images, this all the images in this folder, and then finally the output name of the record file. Do the same for the test .record file. Okay, as you can see, it has successfully created the TF records for train.record. As you can see, 80% of my images in my train underscore labels folder were 1096. Let's make sure these numbers are correct. And it has also successfully created TF records for test.record file. That was 20% of the images, that is 274. Okay, let's move on to the next step. We have these record files now. This is around 20 megabytes, and test record is around 91.5 megabytes. Sorry, train.record. Okay, step 12, download pre-trained model checkpoint. Now we will be using transfer learning. We don't have to start training from scratch. We can use pre-trained model checkpoint. So I will be using this one, SSD MobileNet V2 FPN Lite 320 into 320. So A list of detection checkpoints for TensorFlow can be found here. These are the checkpoints that we can use to train an object detection model. This is the TensorFlow 2 detection model zoo. Just one thing to note, this is important. If you've seen my previous video to train model for custom object detection, as I mentioned in the start of this video, you can use any of these models, any of these checkpoints. But for TFLite, for building an Android app, if you go above, I've mentioned this in my video as well, sorry, in my blog. As of now, TFLite only supports SSD models. The TFLite TensorFlow team, they are working on including other models as well. They might come out with the update soon, but as of now only SSD models are supported. So you can train either of these SSD models here. I'll be using this one, SSD MobileNet V2 FPN Lite 320 into 320. Okay, so just download this checkpoint and unzip it using this. So as you can see, this has downloaded the checkpoint zip file, and then unzip this over here. This is the checkpoint that we need, checkpoint 0 over here. That's it. Move on to the next step. Step 13, get the model pipeline config file, make changes to it and put it inside the data folder. So you can download this config file for this particular pre-trained checkpoint that we've downloaded in the previous step. You have to use the same config file. So we have the config files in the models repository over here. Let me show you. Inside models, go to research directory and then object detection folder, configs, TensorFlow 2. We have a bunch of config files over here. So if you don't have the config files for the model that you are training over here, you can download it from GitHub or TensorFlow's official website. You can download it, make changes to it and upload it to this data folder over here. Since we already have this in this configs folder over here, we have this SSD MobileNet V2 FPN Lite over here. So what you can do is simply make changes over here and then simply copy it using this command, which is what I will be doing. Now these are the changes that we need to make. First change is change number of classes to your number of classes. I have 2 classes, so change this to 2. Change test.record, train.record and label map path to the paths where you have created these files. Remember, the path should be relative to your current working directory while training, so you have to give the paths accordingly, or better yet, give it the full path. I'll show you how to do it. Again, go to your drive, my drive, data folder where we've created all these files. Now go down below at the bottom, the eval input reader, this is for test.record file, and the train input reader, it is for train.record file. So for test.record, just copy path and paste it here. Label map.pptxt file, copy path and give the path here for label map path, and do the same for train input reader. The label map path will be the same. The path to train.record, copy the path, paste it here. That's it. Next step, change fine-tune checkpoint to the part of the directory where we downloaded the checkpoint from step 12. In step 12, as you can see, we downloaded this pre-trained model checkpoint. We have to give the path to this checkpoint I mentioned earlier, checkpoint 0. Just copy path, fine-tune checkpoint, this one, we are using transfer learning, so just remove this dot index, and that is it. Now the next change that we have to make is change fine-tune checkpoint type to classification detection depending on the type of your model. I'm training a model for object detection, so I'll change this to detection. Okay, next change batch size to any multiple of 8 depending upon the capability of the GPU. I'm using a free version of Colab, so this does not have a very huge RAM, so I'll be using batch size as 64. If this gives you error, you can use a lower batch size 48, 32, any multiple of 8. Obviously this will affect the training time. The larger the batch size, the faster will be the training process, obviously. So if you have a good GPU, you can give it a larger batch size. I'll be giving it a batch size of 48, and then finally change number of steps to the number of steps you want the detector to train it to. The number of steps default here is 50,000. That is more than enough. Again, this depends on the data set that we are training. For simple data sets, 10,000 steps might be enough. For some, 20,000. This will vary depending on the data sets. So you can give whatever number you like. Obviously we can stop the training whenever you want manually. If we see we've reached a desired value for our loss, we can stop the training. For now, if you're just starting out as a beginner, just leave it as it is, 50,000. That should be enough. Make the changes, save the changes, Control S, and we've done that. Now copy the file from the configs folder to the data folder, and now we'll see that we'll have the config file copied here. Just open this and double check that all the changes are reflected here. Yes, okay, everything seems fine. Now moving on to the next step. This is load TensorBoard. Now this will help you visualize the progress of your training. Right now it won't give any output as we haven't started the training process, but once the training process starts, you can come over here and click on the refresh symbol over here, and this will show you the output. Okay, now let's move on to the training process. Navigate to the object detection folder in Colab VM. Again we are navigating to this folder, object detection, as we have all the files, the script files over here. This is the script file for training, model underscore main underscore tf2.py script file, and we have other script files here that we will be needing later on. Export TFLite SSD graph, export inference graph script files. So okay, now let's start the training process by running this step 15a. This is the command. Let's run this. I'll quickly go over the usage. This is the path to the model's main script file. Again, pipeline config path, the config file that we edited and copied to our data folder over here. Give the path to it. Okay, and then model directory. This is where we'll be saving our checkpoints during the training process. Okay, for best results you should stop the training when the loss is less than 0.1 if possible, or else just stop the training when you don't see any significant change for a while. But the ideal loss should be below 0.05. Obviously the lower the loss, it is better. Okay, so let's see the progress. Okay, right now as you can see, it might seem as if the output is frozen, but don't stop the training process, as the model underscore main tf2.py script file only gives the output every 100 steps. So depending upon the batch size, as I mentioned earlier, this might take a while. Lower batch size means this will take longer, so we'll wait for a while. Just be patient. Okay, as you can see, now this has given the output at step 100. This took a few minutes. Now at step 100, as you can see, the loss is at 0.432. We'll wait a few thousand steps before we stop training so that the loss gets below 0.05. Now since this is for demonstration purpose, I'll stop this when it goes below 0.1. And another thing, this saves a checkpoint in this training folder that we created every 1000 steps. This created this checkpoint 1 at step 0, and this will create another checkpoint 2 at step 1000. So if you get disconnected or lose your session, you can restart training from step 1000. You don't have to start training from step 0 again, but only after we get checkpoint 2 saved over here. If you get disconnected before that, you'll obviously have to start training from step 0 again. So I'll pause this again and be back when we reach step 1000 and we have a checkpoint saved over here for that. So okay, so now we're at step 1600. As you can see, the loss is as 0.248. So as I mentioned earlier, this saves a checkpoint every 1000 steps. So if we go over to the training folder, as you can see, we have a new checkpoint saved over here. So if you get disconnected or lose your session, you can start training from step 1000, that is checkpoint 2. I'll quickly show you how. Stop this. I'll terminate the session as well. This is in case you get disconnected. Just reconnected. I've mentioned this over here under retraining the model. If you get disconnected, all you have to do is run these steps 1, 5, 6, 7, 14 and 15. You don't have to run all these steps as we've created and uploaded all the files already. Now the Colab VM has lost all the variables, so we'll have to run a few steps again. Okay, so once you go through this a few times, you'll know what steps you have to run. So obviously you have to run this first step, that is import libraries. You can skip step 2, 3 and 4 as we've already uploaded all these files. Mount, drive and link your folder. Run step 5. We should have our drive linked over here. Yes, okay, it's done. Now run step 6. Clone the TensorFlow models Git repository and install TensorFlow object detection API. Again, just run this step. Okay, this has cloned the repository and now it's installing the object detection API. Okay, that's done. Now the next step is optional. Just run this to check if the installation was successful, as we did previously. Okay, that's okay. Now we can skip all the next steps 8 to 13 as we've already uploaded and created these files. So just jump to step 14, that is load TensorBoard. So we have a few event files over here and the checkpoints over here. This will give you update till 1600 steps. Okay, now finally move on to the training step. Navigate to the object detection folder and again just simply run this command and this should automatically restart the training process from the last saved checkpoint. That is checkpoint 2. Checkpoint 1 was for step 0, so you should have the next checkpoint after that, checkpoint 2, or any other checkpoint after that to restart the training from. Again, as I've mentioned earlier, this only shows output every 100 steps, so don't think that the output has frozen here. Just wait for a while and then it will continue from the last save checkpoint. Okay, checkpoint was restored and now it will start the training process. Okay, before it gives us the output, I want to just quickly give you one more instruction. this model underscore main underscore tf2.py script, the latest script, should automatically start training from the last save checkpoint. But just in case if it doesn't, you can just try one thing. Let's change the fine-tune checkpoint in the config file to point to the latest checkpoint, that is checkpoint 2 in this case. Again, as of right now, I'll say this again, you don't have to do this. I'm just giving this in case you see it's not restarting the training process from the last save checkpoint. So what you have to do is go into the config file and under here in fine-tune checkpoint, the path we gave to the pre-trained checkpoint model, what you have to do is give the path to your latest checkpoint that is inside the training folder to this checkpoint 2, copy path, paste, again remove dot index, and that is it. Save this and we can run. Again, this is optional in case it doesn't work, but I've run this a bunch of times, so this script does restart training even if you don't make any change. I'll just revert back to the previous path. So I haven't made any change. Let's see from where it picks off the training process. Okay, so as you can see, it automatically restart training from step 1000. That was checkpoint 2, as I've mentioned a few times. So okay, the loss here is at 0.232. Now I'll just pause this here and come back later when the loss has reached below 0.1. I stopped the training at around step 35,000 as the loss had gone below 0.05. Although I noticed at around step 13,000 or somewhere between 13,000 and 15,000 the loss had reached below 0.1, but it still kept training. So you can stop at around somewhere between 0.05 and 0.1. That's okay. So as you can see, I have checkpoint 36 over here. Since checkpoint 1 starts at step 0, checkpoint 36 is at saved it at step 35,000. So okay, now after this let's move on to the next step. Okay, this 15b validation step, this is optional. Okay, what this step 15b does is it evaluates the model that we have just trained in the previous step using this command. So 15a is for training and 15b is for evaluating the model. So the only change in the command is that we have an extra parameter over here, checkpoint directory. This is the extra parameter that we use in this command. Rest the entire command is the same as the previous one. Now what this checkpoint directory points to the directory with checkpoints produced by the training job. So the evaluation events will be written in model underscore directory. Both are the same, the model underscore directory and checkpoint directory. I have given both the same paths. Now what this will do, it creates an eval folder inside this training. Right now we have only one folder, train. Okay, now moving on to the next step to test your train model. Now we will be doing that. For that, first we need to export an inference graph. We will be using the script from the object detection folder over here. As I mentioned this earlier in the video, that we have all the required scripts over here. So one of them for TensorFlow 2 is exporter main v2. This one, this creates an inference graph. This is the command python exporter main v2 .py script train checkpoint directory, again the path to the training folder where we have all our checkpoints saved, then the path to your pipeline config file, And finally, the output directory where you want to save the inference graph. Just name this as inference graph. This will automatically create a folder named inference graph inside the data folder. Over here, this will create a folder named inference graph and save the inference graph inside it. Just run this to create your inference graph. Go to the data folder. Let's wait for it. Make sure there are no errors. Okay, you might get a few warnings, but that's okay as long as there are no errors. Okay, as you can see, assets written to the inference graph folder, and also writing pipeline config file to the inference graph folder. Let's go over here. Okay, we have this new folder generated. We will have the inference graph over here. This is what we need, saved underscore model.pb file. Okay, again we have the pipeline.config file and the checkpoint, but what we need most importantly is this saved underscore model.pb file along with the variables and assets over here. Okay, now let's move on to the next step. Now that we have our inference graph, test your trained object detection model on images. So now we will run this cell. Before that, you can run this cell. This is optional, just to download a bigger font for the detection boxes. This downloads and unzips it and then changes the font to a bigger size. This is optional. Okay, now this is the main step to run inference on your images. So you have to make a few changes. The path to saved model should remain the same. I've already given the path to this saved model folder. Okay, so that will be the same, and label map.pbtxt file will also be the same. It is inside the data folder. Okay, now the only change you have to make is your image path. I have created a folder named mask test images, and I've put a few images named image1.jpg, image2.jpg and image3.jpg. So that's what I'll do. I've given the path to first image, and that's it. You don't have to make any other change. You can make changes accordingly if you want to change, for instance, like your minimum score threshold. Okay, this will set the minimum probability for the boxes to be classified as true. That is for the object detection 0.4, that is 40%. So if it is less than 40%, it won't give the output for that. You can change this to whatever you want, and again you can tweak some of these values to get a bigger graph or plot. Now I'll just run this for this image1.jpg. Okay, it's loading the model right now. Then it will run inference. After that, let's see the output. Okay, as you can see, we have the output for this over here. It has given the output with mask for this with 100%. That's good. Now let's test it against another image without mask. I have this folder with the image1.jpg. I will give the path to this. Simply copy path, paste it here. Now again, since we have already linked the folder, we don't have to write this every time. You can leave it as it is, that's not a problem, or you can just write /my drive. Both will work. Run this. This is for this image, so it should give an output of without mask. Okay, so as you can see, it has given us the output for this as without mask. So okay, that means our model is working fine. Okay, so we can move on to the next step, that is converting a trained SSD model to TFLite model. We will be converting the trained model from above to a TFLite model so that we can deploy it on a mobile device. We can deploy a TFLite model to any mobile device like Android, iOS or Raspberry Pi. So okay, let's begin with the conversion process, converting the above trained SSD model to TFLite model. So we start with step 17. For that, first you have to install TFNightly. As I've written this over here, TFLite converter only works with TFNightly for now. This is for TensorFlow 2. So just run this step. It's simple. Okay, so this has successfully installed TFNightly. Now installing another version of TensorFlow or TFNightly asks you to restart runtime in order to use the newly installed versions. So when you restart runtime, you might lose all the local variables. So in that case, you will have to run steps 5 and 6 again, which is to mount your drive, link your folder, and then the sixth step, it is clone the model's Git repository and install TensorFlow object detection API. But right now I had just run all those steps, so I did not lose any of my variables in the Colab VM. And now we can move on to the next step. Make sure the current working directory is this one, and then run this command. We're using the export TFLite graph underscore tf2.py script file. Okay, as you can see, I am in the wrong directory. I forgot to change the directory, which we did in step number 15. So now that you've seen this error, if you get this error anywhere in this Colab notebook, you know how to fix it. Just make sure you're in this current working directory, and now this will work. Okay, this is the current working directory, and we are using this file export TFLite graph tf2.py script file. This will create a TFLite graph in this directory in a folder named TFLite. This is the output directory. It automatically creates this folder and saves the graph in it. This is the train checkpoint directory, again where we have saved all the checkpoints during the training process. This is the config pipeline, and this is the script. Okay, so it's done, as you can see. Assets written this location over here as well. Let's go ahead and check it out. Go to my drive, tf2 data. As you can see, we have this new folder over here. This is the TFLite graph that we need. We need this entire folder for TensorFlow 2. For the next steps, just follow along. Okay, for the next step, step number 19, converting the TF saved model, this one, to the TFLite model. Okay, the TFLite model is what we will be deploying on all the mobile devices. So first, check input and output tensor names. This will show you the input and output tensor names that you might require if you're using some different files. This is optional. You don't have to do this. I'm just showing you how it is done. This is one of the methods how you can see what the names of the input and output tensors are. As you can see, we've seen the output names of these tensors. Okay, let's just move on to the next step, and this is the main step where we will be converting the saved model to the TFLite model using TFLite converter. So you have to use either method A or method B. Don't use both the methods, because if you run this will create a file detect.tflite, and if you run this cell again, this will overwrite the previous TFLite model. You can change these names if you want, and also refer to this article over here. As you can see, use either method A or method B. The first method is using command line tool. This is using command line tool, and the second method is using Python API. There are many ways to do it. I've given a few ways over here. Okay, I've given a simple method over here with optimizations, etc. This is the most simple command line tool method. So if you're a beginner, I recommend using this method just so you get a grip on how this is done. Okay, and later on, when you've learned a bit about TensorFlow and TFLite, you can experiment with other methods. I've given these two links over here from where you can understand more about these steps. So just visit these official TensorFlow website. As you can see, there are two methods for TensorFlow Lite Converter, the Python API. This is recommended because it makes it easier to convert models as part of the model development pipeline, apply optimizations, and add metadata, and has many more features. This is only supports basic model conversion, but I am recommending this one for now, the first one, since it's very simple for beginners. Again, as I said earlier, once you get a grip on this method, you have to learn more about this method, because this allows more optimizations, which means you can get a better model out of it. As you can see, we have post-training quantization methods here. These are a few optimization methods. What these do, as you can see, float 16, full integer, it gets smaller, the speed increases, etc. There are many other ways for optimization. Okay, go ahead and read those. It improves model accuracy. So okay, that's it about this step. So now just simply run this, and this will create the TFLite model in this folder itself. I've given the output location inside this folder, and the name will be detect.tflite. As you can see, we have this detect.tflite model. Finally, we have the TFLite model. This is around 11 megabytes. Download it on your system. Also, it will be saved on your Google Drive, so you don't have to worry about downloading it. I'm just doing this to show you what the next step does, or better yet, I'll change the name for this. detect1.tflite. This has a few optimizations applied over here, as you can see. So I'll just run this, and this will create the TFLite model, the new TFLite model, with these optimizations applied to it. Okay, so we have the new model, but it will be smaller in size. As you can see, it is only 3.44 megabytes. So okay, this is how we convert the saved model to TFLite model. And that's it. Now we have the last step in this Colab notebook. It is create TFLite model with metadata. So one thing, previously we did not require TFLite model to have metadata attached to it, but the new TensorFlow Lite samples on the TensorFlow GitHub require that the final TFLite model should have metadata attached to it in order to run. You can read more on this over here. Adding metadata to TensorFlow Lite models. You'll get a better understanding of this over here. So okay, just follow these steps to create the TFLite model with metadata. Pip install TFLite support nightly. Okay, change directory to data, change directory to TFLite, and I'll create another folder named TFLite with metadata so that it is easy to differentiate between the two. We have another folder here named TFLite with metadata, and now finally run this step. As you can see, the only three things we need to give over here are these three paths. The model path, you can let this as it is. A label file also, you can let this be as it is. And the final destination path, save to path, you can give whatever you want. I have given this folder TFLite with metadata. I'll save it over here, and that is it. The only thing we need to do over here is that we have to create this label map.txt file. Okay, this is different from the label underscore map.pbtxt file. That was different. This is like the label files with only the class names written in it, unlike the label underscore map pbtxt file which had id numbers mentioned in it. The label map.txt file should be like this, with mask, without mask, just the names of the two classes in it. Create a notepad and upload this to this data folder. So let's do that. Name this as label map.txt. Write the names of the classes. Save it and upload this to your drive in this data folder. File upload. Okay, so now that's done. Refresh this, we'll see this file over here. Okay, this is the label map.txt file that we need over here. Don't confuse it with this label underscore map.pbtxt file which we had used earlier on. This is something like this, with the id number, the name, that is different. Okay, so that's it, we're ready to go. Just run this step and this will create the new TFLite model, the final TFLite model with metadata attached to it. Okay, this metadata has the name of the model, what it does. It is an object detector. You can write anything you want, mask detection. You can make changes over here. Whatever you want. I'm using an SSD model. Okay, and what does it do? You can write the description over here. This detects masks in a image or a video, so you can write that over here. So that's what metadata does, and it also attaches other necessary information to it. Okay, so it's done and the files have been populated. Now if you open this folder TFLite with metadata, you will see this new TFLite model. This is the one that we need for the next part of this video. This is the final TFLite model with metadata attached to it. Okay, I've downloaded this, and this will also be saved in your drive, so that's good. And now finally we can move on to the next step, the last and final step of this entire process of building an object detection app using TF2. So this is download the TFLite model and adjust the TFLite object detection sample app from TensorFlow's GitHub. Now we're done with this Colab notebook and everything over here, so you can just close it. Now we have all the files in our drive, so we don't need the Colab notebook anymore. Now again, this is the last step that we need. Okay, I'll be covering this step in the next video, part 2 of this tutorial, as this video is already long enough, and the next video requires Android Studio to be installed, and we'll make a few changes inside this object detection sample app inside Android Studio and deploy it on an Android device. So this is also a very simple process, it's not a very difficult process. Okay, I'll be covering this in the next video. So okay, I'll see you in the next one.